everybody. We are going to make a video of the 4 proofs that we have left to do. I'm going to go pretty quickly, so if you want to pause the video, please feel free to do that. On exercise 4, I believe this is page 18, when you go through and you look at the givens, it says angle MNP is equal to RPN. You want to make sure to mark those angles, MNP and RPN. Right away, you should notice that that's an entire whole angle. Then it says angle 1 equals angle 3. You want to mark those as well. And then QN equals QP. QN equals QP. You want to make sure that you mark all the videos. The biggest thing, too, what I like to look at is I like to look at what we actually have to prove. MQ is the part of the picture that we have to prove, and RQ. So right away, I would kind of try to take note that we want to prove these 2 triangles are equal. Triangle MQN and RPQ. Again, the first thing you want to do is you want to make sure that you have your givens written in your table, and don't be lazy, make sure you write that. The next step that I have, I'm sure that you all are getting really good at this, angle 5 and angle 6 are in fact equal and vertical angles. Mr. Carpenter likes to do this in 2 steps, so this would be step 2 and 3. Angle 5 and angle 6 are vertical angles, and then step 3 would be angle 5 equals angle 6 because vertical angles are equal. My class just does it in 1. Angle 5 equals angle 6. Angle 5 and 6 are vertical angles, and vertical angles are equal. Very important that you recognize that. We're very close to having one of the 5 angle measures. We have a side here, and we have an angle here. We still need to get angle 2 and angle 4. Right away, you should recognize that you have a whole angle and you have a part of an angle. The whole angle is the MNP that you marked. The part of the angle is angle 1. And RPN is the whole angle, and angle 3 is the one that you've already marked. So angle 2 equals angle 4 by subtraction. So I'm going to go ahead and get rid of all of the marks that I have here so that we can clean up what we have just proven. We've taken 2 vertical angles and had them equal to each other. We had a whole angle, and we had this angle, and we had a whole angle, and we had this angle. We now can say angle 2 is equal to angle 4. And then we knew that these 2 pieces were equal. We now have equal triangles, MNQ. These should have a triangle symbol in front, triangle MNQ, and triangle RPQ by angle, side angle. And now we can prove the corresponding parts. Please remember, if you're not very good at remembering corresponding parts of congruent triangles are congruent, or the acronym CPCTC, you need to make sure to do one of those. If you're not good with keeping the letters straight, make sure you write the entire sentence. That was page 18. Now you can go to page 20, and we are going to look at question number 4. Again, we said that the proofs stay pretty much the same. It's just the pictures that get more challenging. So let's take a look at our given. Again, please make sure that you write all of the given. And let's mark some things that we know. We know angle 1 equals angle 2. I'm going to mark those. We know that QN equals RN. There's QN. There's RN. We have a vocabulary word of perpendicular. Right away, we need to know that that goes into our proof at some point. I'm not going to make any marks until I actually write that in my proof. And we also know that MN equals PN. So we've just gone through the given and tried to figure out what was happening. We've written our given. And now we need to take a look at some stuff that we know. Again, we need to deal with the perpendicular lines. So angle SNM is here, is a 90-degree angle. and SNP is a 90-degree angle. And we know that because perpendicular lines form right angles. Again, what you should be thinking is that this right angle is now a whole thing. So this angle here is a whole angle. This angle here is a whole angle, and we have a part. So right away, you should be thinking that subtraction is going to help us get 3 and 4. But let's go ahead and finish the perpendicular lines. Perpendicular lines create right angles, and now we know that all right angles are equal. So there was a lot going on right there in that one step. We found the right angles. We know that they're whole angles, so we should be focusing on the fact that now we can say angle 3 and angle 4 are equal by subtraction. All right, so let's take a look at what we have now. Let's clean it up a little bit. Okay, let's clean this up. We found angle 3 is equal to angle 4 by subtraction. We were given the fact that QN and RN were equal, and we were also given that MN and NP were equal. We need to prove that QM and RP are equal, so that means that we need to prove these two triangles are equal. And if you take a look at that, we now have one of the 5 ways to prove triangles are congruent. We have side angle side, and again these should have triangles. Please make sure that you're remembering that the order of the letters is important. Q corresponds with R, N corresponds with itself, and M corresponds with P. Make sure the letters are in the correct order. And then again, we need to prove that we have 2 segments equal, the 2 segments being QM, which is here, and RP, which is here, and we use corresponding parts. So you can write the sentence, or you can use corresponding parts of congruent triangles are congruent. Either one of those works. Please make sure that you write one of them. The next proof that we're going to is just below that. Again, let's keep reminding ourselves that the proofs stay the same. It's the pictures that get challenging. So we look at this given for number 5. AB equals AC. These are a little bit harder to mark because you have, again, what should be thinking in your mind is a whole piece. So AB equals AC. We know that AD equals DE. In your mind, just thinking ahead, you have a whole piece and you have a small piece. You should be thinking subtraction at some point. And then we also know that DC equals EB. So that's this piece right here. It's kind of hard to mark that. We're going to fix that in just a second, but I'm just showing you the pieces. So we have DB equals EB. We have to prove that angle 1 and angle 2 are equal. This is where the picture gets challenging. Angle 1 is a part of triangle ECB. I would try to extract that triangle. It will help you a little bit. Here's ECB. Angle 1 is right here. That's what we have to prove. We do know that in this particular triangle, EB is one of the equal lengths. The other triangle, angle 2, is right here. Again, the picture is the challenge. If you can extract the correct picture, then you won't have a problem with the proof. So if we take out the triangle DCB, angle 2 is right here. And again, the other equal piece to EB is DC. So we've kind of got a piece already. Notice that DB, which is right here, is part of that subtraction thing. DB, again, is right here. EC is part of that subtraction thing. EC is right here. So we should be able to get that. you can go ahead and mark that DB equals EC by subtraction, since you have the whole and you have the small piece, and you have the whole and you have the small piece. Now, taking a look at this, you should be able to recognize right away that there is a shared piece in these overlapping triangles. BC is in the green triangle on my picture, and BC is in the red triangle, also on the picture that I extracted. So BC is a reflexive piece. So what we've got now is we've got side, side, side for the two triangles. Again, please make sure you use the triangle symbol. Please make sure that you have corresponding letters in the same spot. D corresponds with E. C corresponds with, C corresponds with B, and B corresponds with C, going back and forth in those triangles. We have to prove angle 1 is congruent to angle 2. Those are corresponding parts. And so therefore you use corresponding parts of congruent triangles are congruent. Again, CPCTC is okay if you can remember that. The last question we're dealing with is question number 6. The picture doesn't look too bad. We have a vocabulary word, OP bisects angle AOC. We also have angle 1 equals angle 2. We also notice that the proof has a different sort of statement that we have to make sure that we are able to prove, and it has the keyword of equidistant, which just means same size or equal distance away. I'm going to zip through this one fairly quickly as well, so make sure you pause if you need to. Remember that angle bisector means that we have two equal angles. So we should recognize that since OP, which is in the middle, bisects this angle right here, that angle 3 equals angle 4. Here's the trick. The trick is we have OP reflexive. I think you could have noticed that right away. But what you also have is you have two straight angles that can be reflexive as well. If you notice, the angle 1 is a part and angle 2 is a part, and both are a part of a straight line. So if you say that you have a straight line, then you can use subtraction to get to angle 5 and angle 6. And so we want to, that's something that's very different. We have to create the angle before you go ahead and use subtraction. So we create the angle by saying that we have a straight angle or a line that's reflexive. I'm going to put the letter R right here. So OPR is reflexive, and then we can go ahead and use subtraction. The rest of it is a piece of cake again. We have two triangles that are equal by angle, side, angle. Again, please make sure you put your triangles and make sure that you have your corresponding letters labeled. The last part of this is what we have is line segment AO equals CO by corresponding parts. Now, if you look at your picture, AO equals CO, that's right here and right here. Those are the corresponding parts. Unfortunately, the last step doesn't say just to prove that. It says use A and C are equidistant from O. So is A the same distance from O as C is? And because they're the same length, that is in fact the case, and this is how you would write it in words. A and C are equidistant from O, and the reason is if two segments share an endpoint and are congruent, so they share the endpoint of O, those segments are congruent, then the other endpoints are equidistant from the shared endpoint. That's the trick. Honestly, I'd be so happy with 1 through 6, and then you can just add in the definition of equidistant. Great job, everybody. Thanks for paying attention.